During the winter break, I had a thought. What if I made a small hand for my finger? This idea came to me while I was repeatedly watching a video of a geared animatronic finger on YouTube. You know, as one does. So without skipping a beat, I spun my chair around and pulled off my finger hand straight from the toucan's beak, sat back down. But with the hand on my hand, I thought to myself, wow, this is lame. Can't even pick things up. For this project, the first thing I needed to create was fingers, and I decided to base my first design off of the one from the YouTube video. Only smaller, a lot smaller. To find the exact limit of the shrinkening, I started by seeing how small of a gear I could print. Here's what I got for my first attempt. As you can see, they're pretty tiny, but almost unusable because of poor print quality. I tried again with some setting changes and it still didn't work. This led me to move on to a larger module with smaller tooth count design, and that worked significantly better. After I had the gear size figured out, I went right into designing my first finger. So the positives of this design is that it's incredibly thin, aesthetic, well-contained, and counterintuitively robust. In many of my later designs, I thickened up the walls, and this led to the gear shaft shearing really easily, as shown by this pile of failed attempts. Unfortunately, because of this thinness, this design had a tendency to bend really easily, so I only ended up printing one. All of my next geared attempts all struggled with this shearing problem, but also the conundrum of how to drive the gears. I wanted fingerhand to be fully mechanically driven, which meant some sort of pulley would need to rotate the gear, so I couldn't just have some sort of little motor in there. At this scale, it was a little bit too challenging, so I ended up scrapping the idea of using gears. I did try though, so I ended up trying to fit some sort of key which would be connected to a pulley, and as you can tell by this footage, one, my hands are much larger than the finger hand, so it's very hard to film, and two, it's also just really hard to fit parts together at this scale, especially when I'm using an FDM machine. Compliant mechanisms are mechanisms that are flexible. They bend instead of rotating on a pin or axle. For example, this is a rotationally compliant mechanism that I printed out. As you can see, it can rotate about 90 degrees without any bushing or bearings. Now, compliant mechanisms are often used in cases where you want a really cheap hinge, so most disposable plastic boxes you see will have a compliant hinge. I chose to use them for my design because I could print a simpler finger with basically zero assembly. To start the design process, I did some research on geometry and then printed out some test pieces to get an idea about how flexible the PLA I was using could be. And once I'd broken all these test pieces and measured how many times they could flex, I settled on a design and started printing out fingers. This took many iterations because I didn't feel like using some math to optimize the design, since I was working on this during my free time after some pretty math-heavy courses. Instead, I chose to brute force it. This was my first batch of attempts, all failures. What is neat is some of them I accidentally managed to make a bistable switch, so it's kind of cool. After all these failures, I did end up swapping my design to one based off of a chapter in this book I found online. It is pretty different from this design just because I didn't use hinges and they ended up using this kind of mechanism that you see in this picture here a little bit differently, but yeah, it was based off of this. Now this design proved to be a lot more promising, so I developed it a little bit further till I was happy with it, and then what's cool about this finger design is that it conforms to the object that you're grabbing. So as you can see by the finger grabbing my finger, it does adjust, which means it should be better at picking stuff up. After the fingers, I made the palm and bada bing bada boom, finger hand. Some interesting features of the palm design is that it's printed with really minimal support, no adhesive, and the string is floss. Another fun fact is that it doesn't really work very well because it has no return spring and limited travel. Now normally I would spend like another month fixing and making it work, but I want to move on to more interesting projects, so this is the video of that. However, as an experiment, I think it turned out pretty great, and I learned a lot about designing compliant mechanisms. If you'd like to 3D print one for yourself for some reason, or to edit the CAD to make it work, I've included links to Thingiverse. If you enjoyed this video, like and subscribe. If you didn't, smash that dislike button. Only I will know if you did. Alright, enjoy. Until the next reading break, I guess.